Hello, my lovely Algebra 2 people. This is Mr. Bear bringing you Skill 24. So we're gonna see now how we can solve exponential equations. Notice that we're gonna do these without logs. Not that you know what that even means yet, and no, I'm not talking about the kind you get at school. So we're gonna need to know some exponent properties in order for us to be able to do this lesson successfully. The first property you should always know is that anything to the 0 power equals 1. So exponents of 0 or equal 1, I guess is what I want to write here. So I'm just putting in words here what the property says. Not that you don't know these properties because you've used them a lot, but I just want to make sure that I put it in words. The negative exponent property says if you have a negative exponent, you just move it to the other side of a fraction bar. Now, I do want to make note that when we use this one in our lesson, we may actually be using it in reverse. So like you might have 1 over b to the n, and we'll actually have a need to rewrite it as a negative exponent for reasons that'll make sense when I do problems. What this says is that a negative exponent is on the wrong side of fraction bar. At least that's the way I think of it. Okay? Product rule says that if you are multiplying things that have the same bases but different exponents, you're supposed to keep the same base and add the exponents. So keep base and add exponents. Quotient rule is almost the same thing except we're subtracting the exponents. So we're going to keep the base and subtract exponents. Okay? And then the last one that we'll need to encounter is the power to a power. And what that says is if you have something raised to an exponent and you raise that thing to an exponent, multiply the exponents. Okay? So keep the base and multiply exponents. Okay? And so what we're going to do is we're going to solve exponential equations where we're going to rewrite bases so that they're the same base and use these properties of exponents so that we can actually end up figuring out some equations. There's a theorem that says that if b to the m equals b to the n, then m has to be equal to n. Okay, this should seem pretty straightforward if you have the same bases and you're raising them to an exponent and you see that the two sides are equal to each other, then the exponent should be equal. So that's basically what's going on here. So now let's try some problems out. For example 1, I have 5 to the 3x equals 1 over 125. Well, the first thing that I would want to do is think about that 125, and I want to see if I can write that as something with a base of 5. So if I multiply 25 times 5, I get 125, and 25, whoops, not 2, not sure where I was going with that. I was probably thinking 5 squared. When we look at this, we could see that 125 is the same as 5 cubed. Okay? So now that I see that as 1 over 125, that would be the same as saying 1 over 5 cubed. So let me write this out. Now, if I can make this 1 over 5 cubed just be written as 5 to some exponent, this is where we're going to use the negative exponent property in reverse. So I'm going to think of that as 5 to the negative 3. So we have 5 to the 3x equals 5 to the third. So do you see what I've done there? What I've done is I've tried to make sure that I could get these. Why can't I highlight? Well, I can't seem to highlight, but let me just kind of illustrate here. I tried to get these written so they were exactly the same base. Because once I do that, then all I have to do is set the exponents equal. So now I just take 3x equals negative 3, and this is easy to solve. We get x equals negative 1. And if we wanted to check our answer, if we plug in negative 1 for x, we have 5 to the 3 times negative 1 equals 1 over 125. Well, that's the same as saying 5 to the negative third is 1 over 125. We know that's going to be true. Okay? You don't have to do all that checking of your answers, although if you aren't 100% sure and you just want to verify, by all means, please do so. All right, moving on to the next one. For the next one, we can see that we've got 2 to the 7x times 8 equals 256 to the x. Well, I've got 2 as a base here, and I've got 8 as a base here, and I've got 256 as a base here. I bet you that I could write 8 as a base of 2, so 8 is going to be the same as 2 to the third. So what I'm going to have here is 2 to the 7x times 2 to the third. Now for the 256, I know that, and this is just personal knowledge, 16 times 16 will get me 256. And it looks like 256 is the same as 2 to the 8th. So what I'm going to do is write that as 2 to the 8th raised to the x power. So what I've done is I've rewritten all of these so that they're going to have a base of 2. So now what I'm going to do is apply some exponent properties. On the left side, what I'm going to do is I'm going to add these exponents, because when you multiply things with the same base, you add the exponents together. That's going to give me 2 to the power of 7x plus 3. And on the right side, I have a power to a power, so I'm going to multiply the 8 times x, and that's going to give me 2 to the 8x power. So now you can see on both sides of the equation, we have the exact same base written, so all we have to do now is set the exponents equal. So we have 7x plus 3 equals 8x. So solving this out, I'm going to subtract 7x from both sides. I like to keep my x positive. 8x minus 7x is just 1x, which is just x, so x equals 3. Moving on to the next example. On the next example, we're going to see some quotient property happening. For 64 and 16, you actually are going to have a couple choices as to what base to use. I know that 64 is the same as 4 cubed, and 16 is the same as 4 squared. So I'm going to use a base of 4. But you could have also said, well, wait, 64 might also be 2 to the 6th, and 16 is 2 to the 4th. Okay, so you could have used a base of 2 as well, is what I'm saying here. Okay, so doing that, I'm going to replace those 16 and 64. I'm going to replace those with their equivalent expression. So 64 is 4 to the third raised to the 2x. My denominator here is going to be, let's see, 16 we said is 4 squared to the 2x plus 3. Now on the right side, you might be thinking, oh, well, it just equals 1. But remember that 1, if I write it with a base of 4, is going to be 4 to the 0 power. That's going to be helpful in a moment. So I'm going to write that as 4 to the 0 power. Okay? So now I'm going to apply my power to a power property. So on the numerator, I take the 3 times the 2x. So I'm going to have 4 to the 6x. In the denominator, I'm going to take this 2 and distribute it to 2x plus 3. So I have 4 to the 4x plus 6. Let me make that 4x look a little better. Okay, so now I have this far, and now we have to apply the quotient property on the left side. So 6x, so I'm going to have 4 to the 6x minus the quantity 4x plus 6 equals 4 to the 0. So remember, we subtract our exponents when we are using the quotient property. Because I have this minus sign right before a quantity, I'm going to distribute that minus sign. So I'm going to have 4 to the 6x minus 4x minus 6 equals 4 to the 0. And I know you might be thinking, gosh, this seems like a long problem. A lot of these steps are mental, but I'm explaining every little detail because you don't know how to do these yet. Or at least I don't think you do. My numerator on the left side, 6x minus 4x gives me 2x. And so now you can see that we have done all the work that we need to do. We have common bases on both sides. So the last step is to, of course, set the exponents equal. So to finally solve this out, we take 2x minus 6 equals 0. Add 6 to both sides. 2x equals 6, divide by 2, and we get x equals 3. Okay. All right, now let's go ahead and try the next one. The next one, a little more interesting. For this one, what we're going to do is we are going to rewrite 36. We know that's going to be 6 squared. We know the bottom of the first one, 6, is just 6. I don't need to rewrite it. And 216, if I break that down, let's see, 216. Let's see if we can divide it by 6. 6 and 36. And 36 we know is 6 times 6. So 216 is just 6 cubed. Yes, I know I didn't break these all the way down to all the prime factors, but I was really concerned about getting 6's. All right, so now what I'm going to do is rewrite 1 over 36. I'm going to write that as 1 over 6 squared. Again, I'm writing out every step. And 216, I'll write that as 6 to the third. So now we've achieved getting 6's in all of these, but what we have to do now is rewrite the fractions so that they are just written with a base of 6. So 1 over 6 squared becomes 6 to the negative 2. And now you hear a kitty in the background. And you hear him again. Stop it, I'm working. Sorry. This 1 over 6, think of that as 1 over 6 to the first, so that'll be 6 to the negative 1. And now we've achieved getting everything written with a base of 6. So now we're going to apply our power to a power property. So I'm going to distribute here. That gives me 6 to the negative 6 plus 2x. Multiplied by 6 to the negative 1x equals 6 to the third. Okay, and then we're going to apply our product property. We're going to add these exponents. So we're going to have 6 to the negative 6 plus 2x plus negative 1x equals 6 to the third. And simplifying my exponent on the left side, let's see, 2x plus negative 1x, we have x minus 6. And now we can set our exponents equal. X minus 6 equals 3. So add 6 to both sides and we get x equals 9. Okay, that's how we do it. All right, looking at the next example, for this one, I want you to try it on your own. See if you can rewrite the 9, the 3, and the 27. See if you can rewrite those with the common base. Pause the video, try it out, and then unpause it and see what you got. Hopefully you got what I have here. So now you're going to apply your power to a power property to make those exponents become just one exponent on each three. So try that out. And if you did that correctly, you'll have what I have here. So on the left side, go ahead and add those exponents together and then check your work. If you did this correctly, then you would have had these as your exponents. So now you're ready to set your exponents equal to each other. So go ahead and do that real quick and check your answer. If you did this correctly, you would have gotten x equals 7. All right. So now I'm going to look at example 6. Example 6 is going to be one where you have to do some factoring. So knowing that 32 is just 2 to the 5th, and 8 is 2 to the 3rd, and 16 is 2 to the 4th. This time we had to use a base of 2 because I can't write 32 as a base of 4, and I can't write 8 as a base of 4. So we use 2. Distributing my exponents on each of these, I get 2 to the 5x squared plus 5 times 2 to the 3x minus 15 equals 2 to the 8x. On the left side, I'm going to add my exponents. So let's see, 5x squared. I'm going to have my plus 3x next. And then 5 plus negative 15 makes minus 10. Okay. And now I can just set my exponents equal. So let me change color here, and I'll go to the left and do that. So I have 5x squared plus 3x minus 10 equals 8x. I'm going to subtract 8x from both sides because this is quadratic. So if you look here, it says get your factoring thinking caps on. It's because we're going to have to do some factoring. But the nice thing is, if you look here, it's an equation. All terms are a multiple of 5, so I'm going to divide everything by 5. That'll make the factoring a little nicer. So we get x squared minus x minus 2 equals 0. How do we factor something that looks like this? Well, we're looking for two numbers that multiply to negative 2. While at the same time adding to negative 1. So that would be negative 2 and positive 1. So this will factor as x minus 2, x plus 1. And because both of those factors are just very straightforward linear factors that you can easily read off the answers, x equals 2 is one answer. And x equals negative 1 is the other answer. All right, for this last one, I'm going to talk you through this one relatively quickly. What I'm going to do is, I'm running low on time. We know that 49 is just 7 squared. Okay, and we know that square root of 7, hopefully you remember this, is 7 to the 1/2. Okay, so I want you to rewrite these real quick. And if you rewrote these correctly, this is what it will look like. So now we're going to multiply our exponents on the first part. And then now, because we have a product here, we're going to add the exponents. So we're going to have 12x plus 2. And now we can take 7, or not 7, I'm not sure why I'm writing 7. We can take our exponents and set them equal to each other. So now I'm going to just do that real quick. So we have 12x plus 2 equals 1/2. And if you don't want to deal with fractions, multiply everything by 2. So we get 24x plus 4 equals 1. So 24x equals negative 3. and x equals negative 3 over 24, which is the same as negative 1/8. Okay, and this is how you do it. You'll have plenty of practice opportunities in class.